Okay, so like I said, today is a continuation of section 6.2, which is on inverses. And where we're going to start is where we kind of left off yesterday, where we have an equation that they give us. We're going to be able to graph that, find some points along that graph, and then use those points to help us find the inverse. And then there's going to be a couple follow-up questions that we might have, understanding some symmetry, because that'll kind of tie into what we're doing at the end of class, as well as understanding how we can determine whether a function is, or excuse me, the inverse is a function. Remember, we had that vertical line test. If we draw a vertical line through any point along that graph, will it cross one time? If so, it passes the vertical line test, in which case we have a function. If it crosses multiple times, that is a case where we fail the vertical line test and our inverse is not a function, okay? So hopefully we can kind of keep that in mind, some things that we talked about on Tuesday and what we talked about yesterday as well. All right. So we're just going to go through two examples here. We're going to do examples 1 and 3 to kind of hopefully solidify this process for us. All right. And my first question for you is, if I'm looking at example 1 there, y equals 2x plus 3. What do you think the shape of that graph is going to be? We saw something similar to this yesterday. I have y equals 2x plus 3. Kind of a line. Good, right? Because notice that this resembles y equals mx plus b, right? Some number times x plus or minus some other number. So I know that that constant term is going to be my y-intercept, right, where it crosses my y-axis. The number times x2 there is going to be the slope, which I can use to kind of help me draw my graph. This is in the packet from Tuesday. So if you have the packet from Tuesday, you're good. All right. So what I'm going to do first is plot that point 0, 3. That's my y-intercept. And then, like I said, that value 2 for the slope is going to help me find the other points, right? So I'm going to go up 2 over 1. And then down 2 to the left 1. Can keep doing this in both directions. Go up 2 over 1 over here. Down 2 over 1 in this direction. And I would do this for about 4 or 5 points like we discussed before. And I'm going to draw my graph. Okay. So I have that shape of a line like I saw before. We're in the packet from Tuesday. So if you have that, Alice, that's what we're following along with here. All right. Any questions about how I drew the graph of my original function? Right. Hopefully we kind of understand that point with slope intercept form, being able to draw our graph that way. Now what I want to do is create a table of values. So my question for you, and you can use the points that I plotted. What are some x and y coordinates that I see there for that graph? Because I want to create the table of values and then use that to help me find the inverse.
-2, 1.
So I have -2, -1.
-1, that's what I meant to say.
That's all right. Keep going though. So what about -1?
-1, 1.
Good.
Yeah, 0, 3. Yeah, 1. I believe that's 5. It's 4 or 5. Then we have 2, 6, or 7.
2, 7. If you're ever unsure, you can always take those x values. So I know that we're just kind of looking at the graph and trying to determine it that way. You could also take those x values and plug them into your original equation, right? If you were like, oh, is it 4 or 5? Well, 1 times 2 gives me 2, plus 3 gives me the 5, so I should expect the y value to be 5. And you can do that for any of these equations that were given. All right. In fact, we're going to actually use that in example 3 to help us create our original graph for the first function anyway. Okay. Anybody have any questions about how I found these points? Okay. Now what I want to do, we saw this on Tuesday and yesterday as well, is create a table of values for my inverse. Think about what we've done with inverses so far. What do I know is going to be different about this table of values, or how do I find the points for this table? Flip the x and y, right? So instead of -2, -1, what would my first point be? -1, -2. Good. And I go through and I do this. I keep flipping the X and Y's, or that you can flip each column really for every single point here. So instead of -1, 1, I'll have 1, -1. Instead of 0, 3, I'll have 3, 0. Instead of 1, 5, 5, 1, and then 7, 2. Any questions about how I created that table of values? You understand for the inverse, just like when we're solving for a function, we flip our X and Y's and solve. When we're graphing, we do the same thing with those coordinates. Now what I do is go through and actually plot those points. So -1, -2, 1, -1, 3, 0, 5, 1, and then 7 isn't an integer, but it'd probably be about right here up at 2. Okay. And I draw my line. One thing, and this is actually to my fault right now. One thing we want to get in the habit of doing is labeling which graph is which. So I know that original function that I drew was the f of x. This would be the f inverse of x. So just get in the habit of understanding which is which. Talked about it yesterday. If you might like color code it or do whatever you need to do, just to kind of keep everything organized. Okay. Any questions so far? Because we've taken care of the first half of this problem, which is just to graph not only the function, but also its inverse. Does anybody have any questions? Yeah. Okay. Follow-up question then, is the inverse a function? So remember, this is where we go through and we use the vertical line test to help us determine whether or not it's a function. What that means is, and I explained it a little bit earlier verbally, but let's show it visually. If I draw a vertical line at every x value, am I intersecting this graph at each distinct vertical line? How many times do I intersect the graph? Just once, right? If I intersect it once, does that mean I pass or fail the vertical line test?
Passed.
Pass, good. When I pass the vertical line test, what I can then determine is that this inverse is a function. So we could say the inverse is a function. All right. Or you could just say yes or no, whatever's easiest for you. But really need to make sure that we're in tune with what the vertical line test is and what it helps us determine. Okay. Does anybody have any questions at all about that first example? Everybody good? Okay. Like I said, we're going to go down to example 3 because we're going to look at a different shape of this graph. So for those of you that it might be harder to see, y equals 2x squared is the original function. Okay. Now, before when we were graphing example 1, we knew this is y equals mx plus b. We could tell that it was a line, right? This has a little bit different of a form. We're also dealing with something that has a power of 2. What do we think, or does anybody have any ideas about what the shape of this graph would be? If something has a second power. When we looked at graphs back in chapter 4 and 5, when we were talking about quadratics, what the graph of this would be. Starts with a P. Not perpendicular. PA.
Parallel.
Not parallel. It is PAR though. Parabola. Or parabola, it has that U shape, right? We talked about that with a lot of the even functions. So that's the shape that we should expect to get. And one thing that we talked about parabolas, remember they're symmetrical a lot of times. So when we go through our table of values, hopefully we see some symmetry and kind of overlapping X and Y values. All right. Now with this though, and some examples that you're going to see with graphing, we're not able to just kind of take a slope and a y-intercept and go through and find all of our points. Might have to plug in values to solve. And we did this back in those later chapters, like when I first started here, with plugging in values to help us out. So let's create our table of values. And what I would suggest doing is picking some negative values, 0, and some positive values. So you might want to start with maybe like -2, -1, 0, 1, and 2. Plug those values in and see what you get out for y, and then go through and use those values to help you find your inverse function points as well. Okay. When I plug in -2, this would be y equals 2 times -2 squared. Well, what's -2 squared? +4. And what's +4 times 2? 8. Well, using our judgment off of that idea of symmetry, right? If it's a parabola, we talked about some of the symmetry it might have. What other x value should also have a y value of 8? +2, right? 2 squared, if I did 2 squared, is 4 times 2 is also going to give me 8. All right. So as you go through some of these problems, you start to see some similarities and some overlap in how you would find your y values, and you're doing less work, right? If I were to plug in -1, what's -1 squared? +1. What's +1 times 2? 2. What other x value should I expect to get 2 for my y value? +1. And then if I plug in 0, 0 squared 0 times 2 is 0. Okay. Are there any questions about how I found the x and y values for that original function? Okay. Let's go through now and plot these points. At -2, I'm up at 8. Now, 8's not an integer on our coordinate plane there, but I'm going to plot it just a little bit above the 6. -1, I'm up at +2. 0, 0 is one of my points. At 1, I'm at +2. And at 2, again, I'm up at +8, which isn't there, but we would expect it to be an estimate around that area. So this is the graph of my original function. Again, it's a parabola. It has that U shape. And I'm going to label this f of x. Okay. Any questions so far with how I found those points or how I graphed that function? Okay. Now I'm going to go through and graph my inverse. All right. Very similar question as before. What do I know is going to be different about the table of values for the inverse? It's going to be the opposite, right? My x's and my y values are going to flip-flop. So with that being said, what would my first point be for my inverse then? 8, -2. Instead of -1, 2, I'll have 2, -1. And I'm going to continue this process on. 0, 0 obviously won't change. I'll have 2, 1, and then 8, +2. Okay. Now I'm going to go through and plot those points. All right. So at 8, again, 8's not necessarily on our coordinate, but we can get estimate, excuse me, be here at 8, -2, somewhere around here. 2, -1, 0, 0, 2, +1, and then 8, +2. So my inverse function looks something like this. All right, and I'm going to label that f inverse of x. Again, the inverse notation is f to the -1 parentheses x. Any questions about how I graph that? What kind of symmetry does a function and its inverse have? Remember I drew this diagonal line here? We talked about this not only on Tuesday, but we talked about it yesterday as well, right? It's in your notes. Y equals X symmetry, right? It's always going to be symmetrical over that line. What that means is if I were to fold my paper along that line, those graphs would overlap. Or if you were to rotate one of your graphs along that line, your graph should overlap. So this is Y equals X symmetry. Something that I want you to keep in mind for what we're going to do at the second half of class a little bit later on, all right? That wasn't one of our follow-up questions, but one of our follow-ups is this inverse a function? So again, what we're going to try and do is use that vertical line test, go through and determine whether or not that inverse is a function. So if I'm looking at this right here, will this graph pass the vertical line test?
No.
No, right? Good. Because any point here, notice if I draw a vertical line, I'm intersecting that parabola twice, that sideways parabola, right? Intersecting twice there. It's happening multiple times. So this fails the vertical line test. So then what we would say in conclusion then is that the inverse is not a function. Okay. And just for kind of background, as you're writing that down, what we're testing to see essentially is for every X value that we have, does that X value only have one Y value? That's what it means to be a function, right? It's 1 to 1. Here, notice like at 4, I have multiple Y values. At 8, you can see it in our table. We have multiple Y values, right? So just kind of a background in what it means to be a function and why we're testing that, all right? Any questions about the graphing aspect of what we've done so far in class today? Hopefully this is a little bit of a review of what we covered, not only on Tuesday, but yesterday as well. Everybody good? Okay. Flip over to the next page, the last page of the notes. And this concept's going to be a little bit newer, but still relating to inverses. And what we're going to be doing now is what's called verifying inverses. And this is majority of what your homework's going to be tonight. You'll probably see an example like this on your quiz, which for reference is probably going to be next Friday, so you're aware. But every problem that we've seen so far has been you're given a function to find the inverse, or you're given an equation, go graph it, find the inverse, or you're given a graph and find the inverse. Now what we're given is the function and its inverse, and we want to verify that that's the case, okay? What I plan on doing is just going through step by step, and we'll use example 1 to kind of help us gauge how we would do this, all right? So now we're kind of given the answer. We have to verify that that's the case. The first thing we're going to do is take f of x, so the function that they give us, this original function here, and we're going to plug it into the inverse function, all right? So f of x, we're going to take that, plug it into f inverse of x equation. okay? And one thing that we need to kind of pull on is that idea from section 6.1, that composition of functions. We take one function, plug it into another, and simplify. That's what we're going to be doing here as well. So if you have any questions along the way, please make sure you stop me and ask. We're going to start with the inverse function, so the 1/2 x plus 2. What's that? That's all right. I'm going to zoom in a little bit. Whoa, not that much.
Oh, okay.
So I just rewrote the equation. My bad. Sorry if it was too far. Okay. And now I'm going to take this f of x, so the 2x minus 4. And wherever I see an x in this equation, I'm going to plug that in. Okay. So I'll have 1/2 in parentheses, the entire function, 2x minus 4, and then plus 2. All right. So first step, take the function, plug it into the inverse. Now what we're going to do is simplify. All right. So I'm going to take that expression and simplify it a little bit. What should I do with this 1/2 and each term inside my parentheses? To simplify. Multiply, right? Distribute. So I'll do 1/2 times 2x, 1/2 times -4. Well, 1/2 times 2, it's the same thing as like 2 divided by 2. Anything divided by itself is just 1, right? So I'm going to be left with x. 1/2 times -4, or -4 divided by 2 is going to give me -2. And I have this 2 hanging out on the outside. Well, what's going to happen with the -2 and the +2? They're going to cancel, right? And I'm left with x. If that function is the inverse, you should always be left with x when you plug it in, when you plug the function into its inverse, and vice versa. And we're going to see that in the next section here. Should always be left with x. So that's what that third step is saying. It should simplify to x every time. And one thing that's pretty unique as you're writing that down, think about what kind of symmetry a function and its inverse have. If y equals x symmetry. So when we go through and we find the composition of functions, we should get x out every time if that's truly the inverse, right? So we're kind of seeing that some of those ideas from before connect not only with graphing, but what we're doing here algebraically as well. Pretty cool stuff. Okay. Step 4, we're going to repeat this process, but instead we're going to take the inverse and plug it into the original equation. So we're going to plug that into the f of x equation. Because we want to verify it both ways just to make sure that is truly our inverse. Okay. So I'll take the 2x minus 4. I'll write that down. That's my f of x. And now wherever I see an x, I'm going to plug in the 1/2 x plus 2. What should I do with that 2 and the terms inside my parentheses? Distribute, right? Very similar to what I did before. Well, 2 times 1/2, same thing again as 2 divided by 2. That's going to give me the x. 2 times +2 will give me +4. And then I have the -4 on the outside, or the -4. What happens with the +4 and -4? cancel out. And I'm just going to be left with x, which is what I should get given that these are inverses. All right. So you'll see some examples tonight on your homework where you're given two functions. You want to verify that they are inverses. So you're going to go through and make sure that when you plug them into each other, you get x out in the end. Okay. Are there any questions, excuse me, about this example? Okay. What I want you to do is go through and do example 2 on your own. And then we're going to go over that and just kind of talk about example 3 at the end. And then I'll explain the homework and we'll wrap up for the day. So take about 5 minutes here and go through example 2 on your own. So you're just verifying that that function and its inverse are functions. So you should simplify after plugging them each in for each other and get x out in the end. If you don't get x, you might have made a mistake somewhere. All right, so just be really careful with how you're simplifying. So everybody's going through doing example 2.
Mr. Stackhouse,
Yeah, question.
is that a negative 3 right there, or just a
Yeah.
regular 3?
-3, yeah.
Okay, because I really it was hard to see a little bit.
That's all right. So it's -3x plus 6. And then the other function is -1/3 x plus 2. I know it is a little bit blurry. This thing's not perfect, but. Take another minute or two to kind of wrap this up and then we'll go over it. Okay. Let's go over this. If you're still working, that's okay. Just make sure you are following along as you're kind of finishing up. First thing I need to do is what? Somebody kind of just walk me through at least the first half of this problem. Okay, so I plug the original and the inverse. So my inverse is -1/3 x plus 2. So now wherever I see an x, I'm plugging in -3x plus 6. I have the plus 2 on the outside. right? Make sure that you're kind of separating that function with parentheses so you know what you plugged in for x, kind of how you have to go through and simplify. What do I have to do from this step then?
Multiply.
By what? So what do I have to multiply?
Negative 1/3.
Right.
And then multiply that by -3 and 6.
Good. And then what's that going to give me in the end? So after I distribute, what should I get?
Well, for me, I got x minus 2.
All right. It's all good. So you have x minus 2 and then the plus 2 on the outside. -2 and +2 are going to cancel and you're left with just x, right? Which is what you should get. Okay. Any questions about the first half of this problem? All right, somebody different now help me out with the second half. So what do I have to do from here? Jake? So now I have to plug the inverse into the original. So I have -3x plus 6. And I'm going to plug in -1/3 x plus 2 wherever I see an x. What do I do from here? Good. What happens with the -6 to +6? Leaving x. So I verified that both ways I've done this, I get x out in the end, which is good because that tells me that that function is the inverse of the original. Okay. Any questions about that example or anything that we've talked about so far? Okay. Really nice job with that. I just want to walk through example 3 because it's a little bit different than something that we've seen up until this point. And you might see an example kind of similar on your homework tonight, probably just like 1 or 2 questions. But I want to make sure that we're all on the same page with some like inverse operations and how we can kind of get rid of things to simplify. I have f of x equals the cubed root of 2x minus 8, and the inverse is 1/2 x cubed plus 4. Okay. So now we're dealing with some higher powers in our functions here. We'll start off the same way though, right? I'm going to take this function and plug it into my inverse. So I'll write down my inverse. I have 1/2 x cubed plus 4. And then wherever I see an x, I'm plugging in f of x, right? Well, I have an x cubed. So in parentheses, I'm going to plug in the cubed root of 2x minus 8. And this whole thing is going to be cubed, right? Because you're plugging it in for x, not x cubed. Does everybody understand that? So it doesn't just replace the variable itself in the x cubed, it just replaces the x. All right, and then I have the plus 4 on the outside. Question? You're gonna say what's coming next? All right, hold on for a second. Before we move any further, does anybody have any questions about that idea? All right, so then Jake, what's gonna happen here when I take the cube, or excuse me, when I cube something that I'm taking the cubed root of, it cancels out, right? And what would be left over? 2x minus 8, but this is all still inside my parentheses. So we have to understand something here. When we cube something that's being cubed, it's undoing it, right? Just like when you square something that you're taking the square root of, or the opposite. So like if I have square root of x, to undo that, I would square everything, right? If I have the cubed root of x, to undo that, I would cube everything. And then vice versa, right? If you're squaring something to undo that, you square it. If you're cubing something to undo that, you cube it. So it works both ways. And that's what we're seeing in this example, all right? Well, 1/2 times 2x minus 8, what do I have to do with the 1/2 here? distribute. And I'm going to be left with x minus 4 plus the 4, which leaves me with just x. Okay. Is everybody clear with that idea of kind of how to undo something that's squared, undo something that's cubed, and then the opposite of that? Because you will see an example on your homework tonight. I think there is one where you have to square something or take the square root. And you're doing this process, you want to make sure that you know that they kind of cancel each other out and you're left with everything that was underneath that square root in the beginning. Okay. Everybody good with that? When you repeat this process the opposite way, you would get x in the end as well. If you want to kind of just do that on your own, that'd be great. Are there any questions about anything we covered relating to verifying inverses or anything that we did with graphing? Jake?
What side? So when you plug in the inverse into the equation and vice versa.
Not always. That's why you want to do it both ways, just to verify. And you're going to see an example like on your homework tonight. If you do it one way and it works and you do it another way and it doesn't, they're not inverses of each other. Also, like if you do it the first way to start and you don't get x, well, then you can just stop right there and say they're not inverses, right? So don't try and create too much work for yourself with that. But yeah, always just kind of verify and double check. Your homework for tonight. Give me a second here. I'm just going to go to the folder. Homework for tonight, page 396. You're doing numbers 27 through 37 odd. All right, so just all the odds. If you take a look at these problems, you're doing what we did right there at the second half of class with just being able to take each of these functions and determine whether they're inverses. So you have f of x and g of x for each of these. You're going to plug them into each other and solve for x, essentially. So solve to get x in the end when you're simplifying. All right. You're doing that for each of the odd problems here, 27 through 37. So your final answer should be like equals x, yes, or if it doesn't equal x, then no. All right. When you come in tomorrow, we will go over that and then continue on with section 6.3. So we're done today with 6.2. That was it for all the notes. And we'll be in 6.3 tomorrow and Monday. And then next week, we're going to be reviewing the rest of the week for a quiz. All right. That quiz, though, won't be a part of marking period 3. Right. We kind of talked about that. So as you're preparing here, make sure you understand we have a quiz next Friday, but also that the third marking period is ending. And what I talked about earlier on in the week was this extra credit opportunity. A couple people already turned it in this class and their grades went up pretty decent amount, which is good. I'm giving this as an opportunity because we're not having an assessment to kind of boost your grade towards the end here. If you missed homeworks, if you did poorly on a quiz, this is a good chance for you to bring up your grade. It is due Friday at midnight. Again, I'm not accepting it any later than that. So don't even ask. Okay. And you can turn that in Friday's folder. So if you go to Friday, it says third marking period, extra credit. All of the nitty gritty ideas about that are written in the description, but you can turn that in by midnight on Friday. Does anybody have any questions about that? Any questions about what we're doing the rest of the week or kind of the game plan for next week as well? Okay. There's about a minute left here. So those of you that are at home, you can go ahead and sign off and I will see you all tomorrow. Right. Enjoy the rest of your day. Those of you that are in here, just make sure that you wait for the bell to ring. All right. Take care.